Welcome back, listeners, to the next installment in Data Skeptic Animal Intelligence. Although we're going to do a pretty good number of interviews this season, I'm also going to be joined more regularly by co-host Becky. Becky, can you remind listeners a little bit about your background?
Yes, my name is Becky Hansis-O'Neil, and I'm a Ph.D. student at the University of Missouri St. Louis in Dr. Amy Dunlap's lab. And I study bumblebees and tarantulas, and I do a lot of learning and cognition work.
So how do the words perception and memory fit into your work?
Yeah, so when I study bumblebees, perception is really important because they are constantly evaluating flowers and picking which ones to visit. So, how they can perceive those things is going to be really important. And it's also multimodal. So, they're looking at shape, color, smell, location, all that good stuff. And then they got to remember it if they're going back and forth from the colony. A lot of folks don't know this, but there's a certain percentage of bumblebees that go out on their first foraging flight and they never come back. They get lost. So, their navigational memory has to be pretty good. And then, same thing with the tarantulas. They got to remember what we're trying to teach them. We train them to get in little buckets to measure their heart rates, and they need to be able to remember how to get in the bucket because it makes it a lot easier when you're working with a venomous animal if they know what to do. So for me, that's where it comes in.
Well, I get some of the idea that you can use like rewards, stimuli, and things like that to train, go left or go right, and left and right could be a color or anything else like that. Are there challenges in experimental design to make sure you're measuring something that's actually there versus, I guess, anthropomorphizing in some way?
You bet. So, like when we talked about antlions last week, that's why they tried to train them against their innate bias because they had to turn left or right. So, they wanted to make really sure that they were looking at a voluntary behavior and not a habit. So, that's why they were like, okay, antlion, do you tend to go left or right? And let's train you to do the opposite.
Well, there's a paper I asked you to take a look at this week, or both of us to discuss on this episode. Would you mind sharing the title and giving a quick summary?
It's called Perception in Chess. I know it's not animals, but that's okay. It still has some really important stuff for us to cover. And it was done in the 1970s. So this was I'd say right when we were chess engines, I'd say we're starting to be more of a thing and not just a dream. They were interested in how chess players, advanced players versus beginning players, chunk information. So when they look at a board and they evaluate the position and all the pieces, how are they actually encoding that into their memory? So they had them look at different positions and reconstruct them, and they changed a few different things and measured a few different things to try and figure out what exactly the players were perceiving before they reconstructed positions, which has a lot to do with how well you can play.
Yeah, we had three different types of, I don't know, what are they, participants. We had the chess grandmaster and then I guess the class A master. I don't really know that distinction, but people presumably good and even better at chess. And then our third group, which is sort of like a control of beginners at chess.
Right.
So it's intuitive to me that, yeah, the beginner probably, or a good hypothesis that the experts in chess would have some better recall. Do they do this in a way that's at all similar to the types of experiments you do on animals?
So they do this in a way that's similar to how other people do some experiments on animals, but for me, it's not super similar to what I do. So they're doing in this chess experiment kind of a hardcore cognitive experiment where they're making a lot of assumptions about what's actually going on in the people's minds based on a few outwardly observable behaviors. And usually I'm not worried about that internal piece. I'm like, did you do the behavior or didn't you? So I see this a lot more when people are studying things like birds that have really advanced visual systems or primates as well, things that you can put on a touch screen and actually give them a pretty complex stimuli or complex task.
And then maybe we should spoiler the results a little bit. How are we going to evaluate this and who did the best, at least from your point of view? And then I'll comment.
Well, the master definitely did pretty well, but I was surprised in some of their conditions where all three of them did pretty similarly, like when they had pretty random positions on the board as opposed to positions that made some kind of strategic sense.
Yeah, for me, that's like the key insight. I don't know enough about chess, but I know there's like a thing called a Polish Open, whatever that is. It's like a shorthand. There must be other shorthands that chess players develop, and that's part of the skill. Like you're not keeping a deep encyclopedia in your head; you're keeping like little heuristics in a way, or like
Yep.
summary tools. And they would have those for real games. So a lot of the ones they looked at would be like a genuine middle game or end game from an existing actual game of chess versus like put the pieces on at random where presumably it's like white noise. You wouldn't be able to apply any of your heuristics to recall better what the board is.
Yeah, that's what my interpretation was as well, and that made sense to me. Like, if there's no heuristic or no pattern to recognize, it's just gonna be much harder to remember, and it doesn't really matter if you're a master at that point.
If I recall correctly, the way the experiment works is if you don't get the board perfect, you get another glance and then another attempt until you get it perfect.
Yep.
There again, we see a predictable pattern that the master takes, I think, almost all of them 2 or 3 tries only. Their learning curve is pretty steep versus the A master and the beginner take a lot more rounds and are a lot slower at building up the recall, even with consecutive glances.
Yeah, and once you randomize the pieces, those curves don't level off. They don't, like, hit a ceiling very quickly, so their just shape is very different. And this is similar to our antlions. We saw learning curves there too. So this is a tool that many, many researchers use looking at human and animal learning.
I almost find it surprising that the grandmaster doesn't have some advantage, even on the random board. Like that, just the familiarity with the board and the pieces would be useful in some way. But it really seems like we hit the null hypothesis on those plots.
Yeah, it does. And to me, that was super cool. I was like, oh, I wish I had an experiment that had something like that in it. Yeah, presumably the master's doing better because their library of all these heuristics and patterns that we talked about is just massive compared to other players. And when that library is of no use, it's like, oh, okay, they're not they're not so much better than other players.
Well, I introduced the term heuristic. I can't remember if it appears in the paper, but the output of my heuristic would be a chunk, I guess. A chunking is kind of the way they describe it, that in your memory, you're not remembering. So, like me as a non chess player, I'd have to memorize the X and Y coordinate of each piece. I would have to have like a triple store of values because I don't have any shortcuts to use. But presumably, a chess grandmaster would have like see the relationships of pieces and they would only remember these chunks, these like summary ideas of the board.
Yeah, exactly. And I think maybe as a beginner, you're not giving yourself quite enough credit. I think you'd still chunk some things, but it'd be super simple things like there were three white pawns all in a row. So if you get the XY coordinate for one of those pawns, you can probably get it for the other two if there's three of them. So I think even beginners do some basic chunking, but then yeah, if you're a grandmaster, you can say, "Oh, haha, this is the Caro-Kann defense or opening, and I know where all the pieces go because I've memorized this before." So that chunk is a really big chunk. For me, I was thinking in terms of chunks like castling. So if I see that my opponent is castled kingside and that structure and everything is completely intact, to me that's one chunk. That's no longer five pieces, that's one. So that's a pretty darn cool thing that the nervous system does.
Well, you mentioned something. Was it the Karakov Open?
Caro-Kann, yeah.
All right, so clearly you know a lot more chess than I do. Share a little bit about your background here.
Yeah, so I was really excited that you sent me a chess paper and said, "Do you want to talk about this?" When I was a kid, I played chess competitively. I would never got close to like international master or any of those kind of rankings, but I did play in tournaments, did memorize some openings, did have lots of lessons and practices. When I was in high school, I lived in Idaho, and I was briefly the K through 12 women's champ for a year.
Very cool.
Being able to combine like the cognitive research with the chess is pretty cool, and think about how people actually play chess because I hadn't thought about it too much before. And it's been a long time since I played. I'm way out of practice. I could not set the Caro-Kann up for you on a board.
So, if through science fiction you could play your younger self, would it be competitive or would your younger self win?
My younger self would win.
Aha,
She would have a much bigger library training data set that she remembered than I do.
makes sense. And let's see. So, have you followed any of the like competitive chess stuff? There's been some recent controversy. Maybe it's been a year or so now about alleged cheating and events like that.
Yeah, I followed it a little bit. I'm located in St. Louis, and we have the Chess Hall of Fame here. So I think one of those matches might have actually been in St. Louis now that I think about it. So there's this idea that chess engines are so good that if you're using a chess engine, someone gets you the moves somehow. And that's kind of a crazy story on its own, some of the accusations that flew around last year. But yeah, now the engines are so good, cheating is much more of a concern than it ever would have been before.
It was a few years ago I interviewed Ken Regan, who I think is widely regarded as the expert for checking for cheating in chess, and has spoken at a number of occasions on events like this. And broadly speaking, I guess his work is to not compare you to the engine, because of course the engine makes good moves, you can make good moves too. but how often do you make a move that's atypical for a user but is somewhat typical or matching or surprisingly matching to Stockfish or one of these other algorithms?
Yeah, so how did he do it? What do you remember about it?
He would look at the probability of next move and how often your next move. So if you looked at, like, I guess more traditional games from chess.com or wherever the big databases are, what do typical people do in this situation versus you can quickly query what would Stockfish do or something like that.
Okay.
It's how often is there not an obvious move and you happen to go with the one that's matching what the algorithm does. And I think it's a bit probabilistic in that way. I can't remember the exact specifications, but it's not asking the question how often do you make the same move as the chess engine, because a good player ought to make the same move a lot of the times, especially at endgame. But it's how often do your deviant or unexpected moves, seemingly coincidentally match the engine.
Wow, and do they use AI to do that?
I believe it's more straightforward, like computational and statistical approaches. I don't think
Okay.
there's any AI in Ken's work.
Okay, so they don't feed you like here's all the games from this grandmaster and you need to figure out the probability that the grandmaster would make X or Y move.
Oh, well, now we're debating what the definition of AI is.
Oh, okay, we're in uncharted territory for me.
I guess it's easier for me to tell you why I don't consider AI part of Ken's work. First of all, because he didn't bring it up. And secondly, because the work seems more traditionally statistical. Like, I don't think there was any machine learning involved, or like he takes an embedding of a board and uses that where there's some learned component. It was really just more a frequentist, or maybe there was some
Okay.
Bayesian stuff under the hood, but a more rote mechanical approach.
Fair enough. I think I can buy that. And why that's not necessarily AI.
Sure.
Interesting.
If it was like looking at a history of boards and trying to predict if a specific move was fraudulent or not, because Ken's looking at the whole game as well. I think that's where it would drift into AI.
That makes sense to me because maybe, yeah, you're making a posterior probability of a particular move and you're not worried about so many other variables.
Yeah, yeah. Does this chunking idea come up a lot in your work or similar work?
It comes up a lot in human work.
Mm-hmm.
Human working memory, so our RAM, for lack of a better term,
Yeah.
is limited to about 7 items, but those items can be chunks. You're not limited to, say, 7 pieces on a chessboard, you're just limited to 7 chunks of information. That's something that folks study all the time with regard to working memory. In terms of animals chunking, I think you could have it, but it would be more difficult to study. You'd have to be pretty darn clever about it.
And that seven number, I don't know if this is like folklore or what, but I'm told that that's why phone numbers are 7 digits. That there was some consensus that we had, on average, 7 chunk slots in our memory.
That could be it. I think I've heard that before too. And then I think there's some error around it, so it's like 7 plus or minus 2, something like that. If you had to ask me, I think my chunks are topping out at like 5.
Well, that'll be all right because phone numbers, at least the exchange, the first three will have a pattern. They're sort of regional, or at least they indicate where you bought your phone many years ago when you got it.
Yep, you can shorten those into single chunks.
Well, I was surprised that maybe it was I didn't do good research, but I didn't find a lot of follow up studies that kind of extend this idea.
Yeah, I did the same thing. And what I ran into is the literature is so flooded with chess engine research that it's very difficult to find the cognition research. Though I noticed people had published some books on the cognition of chess. Like it is a field.
Do you have a sense of what they study?
Yeah, I think it would be a lot of the same kind of thing that we're seeing here, possibly in a much more advanced way. Because now they were in this paper in the 70s, they were super excited about eye tracking, and I imagine it was really expensive and difficult to do at that point. But now it would be much cheaper. You could also do EEG studies, potentially MRI, where you're showing a digital chessboard to somebody. So I think integrating the neuroscience has probably made this field just explode.
So the eye tracking, and I say this as an uninformed person, but I always find that a little dubious. I'm not sure if we can precision measure that and really inference from it.
Yeah, so I think the inference is where I also get a little bit hung up, and I wish we had like a good advocate for this. I too struggle in behavioral science when we look at something like eye tracking or say reaction time to see dots that's on a field. That's another popular thing that comes up. And then we make a bunch of inferences about these processes that must be going on in someone's brain or in their mind. But to me, it's a little bit correlative. We don't have technology that can really give you a one-to-one of what's happening in somebody's brain or decision making process. So, like this paper here, where they did less eye tracking and more just, did they look at the board? Did they pause before they looked at something else? I think we have to take those inferences with a grain of salt and realize that there won't ever be like a smoking gun.
That was actually one criticism I had of this paper, that they seem to be categorizing, at least in one of the experiments, the perceptual task, like what the chunking process might have been. Like there's a whole coding scheme of like, did you remember it based on the two pieces are able to attack one another or they're the same color? And they had, a nice couple of properties and they could at least measure that. It's empirical. But it seems like it left out the possibility that people remember a shape or even like the castling thing you were mentioning.
You just can't get every single variable in there. And I noticed that their most, well, that's a fallacy to say it that way, but their lowest p values tended to be associated with putting all of those perceptions together, like shape,
Yeah.
color, like combining them all into one variable, which struck me like, oh, do we have a little bit of an overfitting problem if we just keep adding variables? Is this relationship gonna just look really strong?
Yeah, it was an interesting level of specificity. I think like the summary that we talked about earlier, like it holds up. It's a good paper, but it's like they tried to slice and dice a little bit too much by labeling the moves or something like that.
Yeah, exactly. And I don't know how much I can fault them for that because once you start looking at inner peace relationships, I think it gets very, very complicated. And they did that a little. I think they had like defense and attack pieces. But I can see why they tried to simplify it a little bit. But yeah, the way the study was designed, you're never going to know if you picked the exact right variables that people are cluing in on when they're making their chunks.
Well, I would love to see this reproduced for Go as well, or some other games like that.
Oh yeah, that's kind of a good idea. Or something like checkers where I know nothing about the patterns.
Oh yeah, I would think they would be simpler patterns, but do you know about the Chinook algorithm?
Uh-uh.
So chess or checkers is a beaten game. You will not be able to win. At best, you can tie the game when using the optimal known algorithm, which is Chinook.
Okay.
It's a provably dominant algorithm, so it kind of makes chess a little less interesting to me. I'm sorry, kind of makes checkers a little bit less interesting to me.
Fair enough. Yeah, when reviewing for this episode, that was something about chess that was really interesting to me because the last algorithm I seriously read about was Deep Blue when I was a teenager.
Sure.
So to read about these newer ones and how they're really consistently beating people really reliably at this point was pretty fascinating to me, and that happened really rapidly, sort of as soon as computer hardware caught up and that was no longer a limitation. Folks were just like, we got this, and, and they were able to make, yeah, engines that beat people or beat grandmasters.
Yeah, the right amount of, I think, at least for me, the missing step that Alpha Zero or before that Alpha Go, the DeepMind, that team really brought to bear was, I don't remember exactly what the prediction is, but the board configuration gets predicted now. So you still have maybe the same endgame database, although it can be deeper. You still have the Monte Carlo search, but it's using enough learning of the board position that kind of the magic of ML comes to play.
And how did they start in the beginning when hardware was a concern? Because my thought as a non programmer was, oh, they probably started just trying to brute force solutions in the beginning. Is that what happened, do you think?
Well, there's a lot of pieces to it, and any chess system, whether it be Deep Blue or Alpha Zero, has a lot of components to it. It's like your car. You have an engine, a transmission, a carburetor, all that kind of stuff. Everybody has, or I shouldn't say everybody. I don't know, the whole taxonomy perfectly. Maybe there's some rogue chess engine that doesn't have this, but I feel pretty comfortable saying they all have some version of an endgame database
Okay.
where you can look at a particular board position and know that you've won. That if you can get yourself to that position, you can force a win, basically. Maybe you don't know how off the top of your head, but for sure the software that you're running will find that win. So then you're not really trying to win the game, you're trying to get yourself into an end game where you can force a win. The deeper your database can go, I think they even go like 10, 11, 12 moves out. It means like the root of the tree. So what would normally be an exponential problem has kind of been pre-solved or cached. You're really exploring, how do I get to one of these known good positions? But along the way, you still have to have some heuristic. Is this a good board position? So I think also universal is some board evaluation function. And the simplest ones, like when I had to write a chess engine in college, were you just assign a numeric value to all the pieces. So, like the queen is 19 and a pawn is 1, and maybe a rook is 7 or something along those lines. And you just sum up what you have left. So, that's a nice proxy, but it completely ignores board position, which is very important, right? So, you need a more sophisticated utility function that can look at a board and kind of give you it's just really just a heuristic most of the time, but give you some score that says your likelihood of winning from that position.
That's fascinating because when I was a kid, they taught us point values for the pieces as well to sort of give you an idea of how well you were doing in terms of exchanges. And then, of course, you learn all sorts of heuristics about board position as well and how to quickly evaluate that. And it's not surprising to me that engines, have outpaced people in that regard. Their long-term memory is just functionally different than me with my brain. They can store more. They're storing it accurately, so the way they keep and manipulate that data is different. So their heuristics are going to be much better than my heuristics.
It's possible, especially in today's day and age, where we can say almost for sure now, right, with the advanced systems we have. But the advantage of computers that they can do deep compute and churn through numbers really fast becomes challenging in chess because it's an exponential growth. So it's more about pruning where you go in the tree than being able to explore the tree.
That makes sense to me. And that's so cool. Just thinking about that. And one thing I never thought about, and then in prep for this episode, I looked it up. So I thought, how many permutations are there for games, for chess games? And I didn't realize that this is an unsolved problem and that number is very large. So it makes sense to me that it's a pruning problem. And our brains are just so good at ignoring all the fluff that we have a little less pruning to do.
I'm going to say this only as a parrot, but I've been told by many people, maybe all were parroting the same source that is or isn't correct, but that there are more games of chess, possible games of chess, than protons in the universe.
I have heard that as well, and I couldn't quite confirm it. I think I would have had to dig in the literature a little bit more, but I think it's possible.
Sure, yeah, it's sort of an exponential thing in terms of the path through the game, so it does make sense.
Yeah, and I had never thought about before that when you exchange a pawn for a new piece at the end game, that is causing a pretty much uncertain amount of permutations.
Aha,
I was like,
interesting.
"Oh, yeah," because if you're human, you're like, "I'm just gonna get a queen or a rook, and here we go," or another queen and a rook, here we go. But if you're thinking in just straight permutations, there's gonna be people that are getting bishops and rooks and multiples of those things until they run out of pawns, and if you're just thinking about that mathematically, I think that starts to get you into some pretty big numbers.
Well, if you had continued on in chess, what would have been I guess, the study? If you had gotten a private tutor or whatever, like, what do you work on?
I think for me, I would have needed to start memorizing much more openings and end games. My opening game was always pretty good. Middle game was really strong. I really loved tactics, and then my end games were my weakest. So I think for me, it would have been going over lots and lots and lots of games, especially from grandmasters, and really starting to go through those endings. So when you're just learning, you do drills. They put a king on the board, two rooks, and say, okay, have at it. Learn how to checkmate the king, or a knight and a pawn, stuff like that. So the drill stuff I could do, but I needed my end game library to be much bigger, kind of like the engines.
Yeah, that is an interesting similarity. Although one thing that's very dissimilar in a way that surprises me is the most recent models like Alpha Zero, they start from scratch and they just it plays itself, which sounds like it could be, two amateurs chasing each other's tails, in contrast to your experience where the drill was trying to teach you something specific, you were being guided. Yet that seems to be enough for Alpha Zero to just play itself from basically a random agent all the way till up a few hours later, it's a greater player than the best human around.
Yeah, and maybe it's worth talking about what's special about Alpha Zero in relation to other chess engines and how it learns.
Oh, I'm going to get a quick summary thing I know about because I don't want to miss a point here. I know some of the high points.
While you're looking for it, I can just quickly say that it's a neural network and it works via reinforcement learning. So it's a little bit more, in my opinion, like a human brain than some of the other engines, but that's a very high level biologist, psychologist overview and not computer programming in depth knowledge.
That's fair, though. As soon as there's deep learning involved, it's the possibility of something surprisingly emergent coming out.
Yeah, it was the reinforcement learning that got me. I was like, "Oh, that's cool." Because then your moves are just based on what's the probability that you win or maybe get to one of these, board states that you were talking about, and then you're just more likely to repeat that move because it's associated with this probability of good things happening, and to me, that's fascinating. It sounds simple, but you put a few spins on it, a few bells and whistles, and it becomes really, really powerful.
Yeah, just raw compute scaled up. One simple idea applied with, hundreds of compute hours gets us there.
That's not so different from kids learning to play. When kids learn to play, there's a couple mistakes that they start to make, probably because they get reinforced when they're playing other weak players, and then as they get good, they get punished for these behaviors. But bringing the queen out really early in a game is usually a bad idea. You're sacrificing development of your other pieces, and your opponent can develop their pieces to just chase your queen all over the board. Young players also attempt Scholar's Mate or Four Move, which, if you're playing an experienced player, they just stop you right away, and then your development is slower and your tempo is slower. It's interesting to me. I'd be really curious to look at some of AlphaZero's early games and see if we see any of those sort of bad strategies that are good when you're a beginner playing other beginners that become really bad when you start to play advanced people.
Oh, that is interesting. I don't know if anyone's ever looked into that, but all those games could and should have been recorded. So it would be more the deluge of data to pump through, but you could get a strong empirical answer to that question.
Yeah, I'd love to compare it to kids that are learning. That would be so cool.
So Alpha Zero, I guess one thing I haven't put on the table I should mention is it is like a generic all-purpose game player. Well, not all-purpose. It doesn't play role-playing games, but games that fit a certain pattern, like a fully observable board, or I'm not even sure if that's required, but more sort of traditional board games. So it plays both chess and Go, and it's more famous because it was the first big breakthrough in Go, which chess was the bigger breakthrough before Deep Blue, I guess.
Okay, I didn't know that about AlphaZero. That's pretty cool. It makes sense that it could be flexible like that.
Yeah, totally generic. It just needs to know some, like, essentially the source code for how you play the game or how you would simulate it in a computer as a video game.
And maybe someday it could play role playing games, get an automated dungeon master or something.
Well, you know what? It's interesting there. There's certainly the possibility to have a player character that is an AI, but I would look more at language model work than reinforcement learning work because anything with reinforcement learning needs strong utility characteristics,
Okay.
a clear end game, a clear, probability of reaching a successful outcome, and you don't have the same thing in Dungeons and Dragons or games like that.
I think that makes a lot of sense. I don't want something that's just really good at probabilities. I want something that's going to be engaging and tell a story, and it's not necessarily about winning and rules.
Right, right. If it were about maximizing the inflicted hit points, we could create that very easily with Alpha Zero, but engaging in a storytelling way, that's a different sort of a challenge.
For sure.
Did you follow Deep Blue when that was becoming state of the art?
I think I was still a little bit young, but I remember the games with Gary Kasparov and reading that in the news. I remember when Deep Blue, I think, finally beat him because I know there's a few rounds where it didn't. And then I read about it a little bit later, and there was actually, I remember, a cheating accusation with Deep Blue. And I think it had to do with a couple moves where Deep Blue sacrificed a piece, which at the time they thought the engine couldn't do that, something so counterintuitive as a sacrifice to bait your opponent. And I don't know if there were ever any strong conclusions about it. Have you read anything about that?
So I read Gary Kasparov's book, or I think he's written several, but one that was really about his battle against Deep Blue. I don't recall that specific thing. I know there were two like sessions of it. One, there was an earlier prototype where I believe he really beat the system and the team was kind of friendly with him. And then the next round, which is the one we all know about where he lost, that got all the media attention. And from his perspective, it was clear different forces at IBM were involved, and it was really about them winning, and it was no longer this sort of research collaboration.
Hmm.
I don't remember a specific, like, he thinks they cheated, but there may have been a note about he thought they did some suspicious fine tuning. I can't recall exactly. I could be making that up, but there's a little bit of drama in the book.
Fair enough. And I was reading the very first, these weren't chess engines, they weren't. But some of the very first quote unquote chess engines were automatons where a person sat in a box under the automaton. and played the game. And
Oh, the famous mechanical Turk, yes.
yes, the Turk. So there's been a long history, but I'm not sure in the case of Kasparov if what I read about the cheating is quite true or not, or if it's like what you said, what he said in his book, that there's just a little bit of suspicious fine tuning during play.
Well, there's a similarly suspicious thing in the AlphaGo game against Lee Sedol. There's a famous move 37 that when it happened, everyone thought it was a glitch or a mistake or a bug, as it didn't make traditional sense, but turned out to be a critical pivot point, something like 12 moves later, in a way that was profoundly impressive to Go experts who observed the game.
Huh.
And I think we've seen the same thing in chess. I remember hearing, is it Magnus Carlsen saying something about how
Yep.
like he spends a lot of time specifically playing the chess engine, and that has been like a master class in leveling up, so to speak.
Yeah, I haven't read about his strategies in terms of training, but that's how I would do it if I were at that level.
Sure, I mean it's computer assisted from here on out, I guess.
Yeah, like I said, that computer is going to have way better access and memory of all the chess games that have been put in for it to learn, or in the case of Alpha Zero where it's playing itself. I presume it plays other games as well, or with up with different opponents, but playing with another person just isn't going to get you there anymore. Just fascinating to me. And also a little bit sad in a nostalgic sort of way. There's really something about having an opponent in front of you that I really like. I haven't personally played as much computer chess as, say, some of my friends do. One thing that we didn't touch on in the paper that kind of jumped out to me, because this isn't what I assumed, is they said they didn't really have evidence for grandmasters, quote unquote, seeing or predicting more moves into the future than other folks. And I thought that was really odd.
I'm partially not surprised. And I think this is, if I'm to over anthropomorphize, this is the equivalent of the Monte Carlo tree search that's used in AlphaGo. So it's sort of a smart pruning, how you do your exploration. I think a grandmaster, there's, it's not like their brain is going to kick into high gear and they're able to get 100% out of their CPU and burn more calories during the game than the novice per se. We're all just thinking ahead a certain however many moves in the time we have. I mean, maybe they would have some like, small, like they're 20% more efficient at doing it kind of thing, like because they've exercised that part of the brain a lot. But there's just a limited number of amount of time to use. So I think the Grandmaster is just more clever at shutting down paths earlier than the novice would be.
That strikes a chord with the scientist in me and understanding cognition and then reading in this paper the results. That makes sense to me. It's the completely subjective chess player in me that goes, huh, I just presumed that I can look, maybe at best, I would say, depending on how you're counting the moves, 8 ahead. So a grandmaster must be like 20 something. But maybe I'm just not as good at pruning.
Yeah, it's a little surprising. You would think maybe they were had a marginal improvement, but maybe it all does come down to pruning.
Yeah, I find that I often have to I'm not sure how I would describe it, but repeat myself. So if I'm imagining what I'm going to do and what my opponent's going to do and remembering where those pieces are going to go in these hypothetical moves, that I often realize that I've forgotten something or I've messed something up and I have to redo that memory exercise from scratch quite a bit. So it could also be that grandmasters they don't have to repeat as much. Presuming this is a universal phenomenon, what I'm describing going on in my own head, and that's a dubious claim.
Well, it's interesting though. It's like it's hard to close a door when the whole state of the board is shifting. You can think you've sealed off something, but then a surprising move from your opponent could make it all need to be reevaluated.
Absolutely. This is usually happening when I'm imagining a couple different options for moves, so while the clock is running on my time. So if they do something surprising, yeah, I've got to start from scratch again, but I'm usually going through multiple permutations just when I'm thinking about my moves. Yeah, I imagine grandmasters, they're having fewer permutations than I am, and then they're more efficient with the permutations they do have and probably have a lot of practice of remembering what's going on in their permutations, whereas I have to keep building them from scratch because I keep forgetting what's going on.
Well, one heuristic you could pick as you're evaluating moves is maximize it to two moves. So if you see four options, just pick two out of a hat and spend your time exploring those two rather than exploring too many. Is that part of your calculation or is it not really present in your decision making?
So less than you might think. And this is something I think brains, nervous systems do really, really well. And there's no equivalent for chess in animals, so this is going to be a very like human example. But we are very, very good at looking at the board and saying, I'm not going to move this little pawn over by my rook forward 2 squares because that has nothing to do with what's going on in the center of the board. It gains me no advantage. We're really good at not even considering those things. So usually I'm already narrowed down to 2 or 3 moves by the time it's my turn.
Interesting. Yeah, you're just kind of fighting three fronts then, I guess.
I imagine that's when folks were starting to build proper chess engines, that was probably one of the big problems they were running into in trying to mimic human play, was just getting rid of all those extra moves right off the bat that you don't even need to consider.
Yeah, it's not a good game to try and brute force, that's for sure.
Yep.
Do you have any major takeaways about memory? I mean, I don't know, this doesn't present the idea of chunking uniquely, but there are some, I guess, words of fortune cookie wisdom we could pull away from the paper.
What I took away from this, and then just reading a little bit more about chess and cognition, is that being smart is helpful for learning something like chess, but it's more important that you're practicing, I think. I think that's kind of a comforting thought for all of us folks that aren't grandmasters and thinking about memory and cognition and chunking in the rest of your life, that so much of it comes down to effort and efficient use of your time when you are trying to learn new things.
Definitely.
So I was really pleased to see that the master and then in this study, the person in the middle, class A master, that they did remarkably similar in many tasks. So I was very pleased to say, okay, maybe the difference when I was a kid between me being good and really good had a lot more to do with practice than any raw intelligence. And I think that's kind of a comforting thought.
Yeah, I think there's a lot of truth to that. I'm sure you've heard this 10,000 hours just so story. I don't know that it's fully scientifically been validated or not, but if you get 10,000 hours of deep practice, not just, playing one song on the piano every day, but really approaching new techniques, that's some, kind of the magic mean number of that investment of time will make you an expert in whatever your passion is.
And I agree with you. I think it is a bit of a just so story, but it's kind of a nice one. This idea of
Yeah.
deep practice. And I think there is something to it.
I don't think, I could have done 10,000 hours and become an NBA player, but I certainly could be a much better trumpet player than I am.
Yeah, and I could be a much better chess player. Maybe I could, with 10,000 hours, I could get up to international master. I don't know. That'd be fun. With these more modern chess engines, are they doing anything like chunking?
Good question. Implicitly, yes. Explicitly, no. I don't think there's any like chunking function where you pass in the board configuration and you get back a list of chunks. That is where some of the deep learning comes in. It's to look at a board and effectively develop what in machine learning we would probably call features, or in this case, an embedding. So, a way of summarizing the board through a learned function, a function that ML finds, that you're able to recover the original board, kind of like PCA, principal components analysis. You're going to do that operation, then look at the most useful eigenvectors because they describe the largest portion of the state, or if you want to kind of recreate the original matrix. So, PCA is the very mathematical way to do it, that's just all about reduction of variance. Deep learning and embeddings are doing the same thing, but in a more loosey-goosey way. So they're going to find a function that to your eyes is a black box, but it takes as input a chessboard, gives as output this vector that is very descriptive and useful for evaluating board positions and next move and things like that.
So, do you think there's a reason, and maybe chunking is a black box in the human nervous system, maybe we don't really know what's going on under the hood, but do you think there's a reason that chess engines are not converging with human nervous system strategies for picking the best moves?
Oh, do we know enough about the human nervous system strategy to say?
Yeah, that's I think that's the right question. If I had to think of how chunking works, and this is me totally speculating, there are people that research this that know way more than me and are much smarter about this. But I think when you make a chunk, you recognize the castled pieces, like a castle kingside with the pawns sitting there, that when you see that, you're getting a visual image and you've practiced so much that that visual image triggers connections between your memories, so that visual image becomes one item as opposed to each piece being an item. Yeah, again, that's all speculation. I'm not sure if that's really how it works. So I don't know, maybe we will find out that we are converging with some of these AI engines more than we think.
Yeah, it seems like we could do an MRI study here and probably there would be a result about what areas of the brain light up at different moves, but it's all a little fuzzy, there's something just imprecise
Yeah.
about that approach, I guess, that where blood is flowing in the brain is not perfectly correlated with what's being thought. But there's something there. And, there's something similar in looking at an embedding. Like you can take the embedded version, the vector that describes the board, and do some clever techniques to map back what were the influential parts that led me here. And from that, you kind of infer, like, oh, it noticed this, it noticed that they're attacking or that they're defending or whatever, but it's all sort of inferred probabilistic. It's not super clean, but it is like an empirical process that you can follow.
I think what we're gonna need, because you're right, we could do MRIs, and you could argue all day about what more blood flow or higher metabolism in part of the brain means. But I think we need the connectome. We need to see neuron level activity to really pick apart what's going on during chunking, I think.
That would be super interesting. Although, what is it, 10 to the 10 neuronal connections in the human brain, something like that?
Yep, we're not there with people. I think we're getting better at just mapping, but actually looking at the electrical activity and specific dendrites and synapses. We're not there. But and I'm hoping we'll get to talk to some of these people this season. We're seeing more and more research on model organisms with much simpler nervous systems, where we're starting to just scratch the surface of that kind of detail, and it's really exciting. Do you think there were any key innovations in chess engines that allowed them to beat human players?
In the chess engine, so going back to Deep Blue, I guess there, I don't know enough about it. I think that was a very highly specialized solution that even, like, I'm not sure if this is true, but like some of the hardware was developed, or at least whatever kind of mainframe local network of machines, it was like all very engineered to win the game of chess at that period of time, versus AlphaGo, which is meant to solve a more general problem, that it also happens to be good at chess through that process. So, what's really changed in that period of time is not so much theory and philosophy, but a little bit to some degree, but more so we now had the hardware to do it. We didn't need a specialized system that was running super state of the art. As GPUs became available, massively parallel computations became available, it was easy for a more generalized win at this game approach through reinforcement learning to emerge, rather than something quite as specialized as Deep Blue was.
That makes sense to me that it was really a hardware problem at the root of it. And now that we have much better hardware that we can actually make chess engines that are efficient enough to beat people. Are there any games left that we could build engines for? Or are there any where humans are still the master? I don't know much about Go.
Well, that's a great question. So ultimately, I think it's safe to say that Go is broken, that it's going to be almost impossible for a human to beat a state of the art Go engine today. And yeah, I don't know what comes next. There's no obvious progression. To go from chess to Go made perfect sense. I know Diplomacy is a game that AI has been winning at recently, and which is a more open game. There's a lot of like natural language in it and negotiating with players. Poker, it's getting better at, but it's not like there's a winning end game kind of thing. So it's more fuzzy as to what comes next.
Yeah, maybe it's like Settlers of Catan or
True. Yeah,
something,
yeah.
something like that. Okay.
Or yeah, what can't be beaten? That's the real challenge. You can come up with any classic board game, and there may be some issues getting it formalized or stated in a way that AlphaGo can play it. But it would be truly surprising if a meaningful game couldn't be beat with modern technology.
Yeah, defining the meaningful game part, I think, is difficult. I wonder, I'm just thinking out loud, or maybe something like Magic the Gathering could be kind of interesting. But I'm sure there's people that are working on that, things like that.
I haven't seen a lot of good research on it, but I know you can play it online, which means the whole game is digitized. Like I would worry that there would be some open-ended text, like in one of the magic cards that says this is a spell that just works in some novel and unconventional way, and you have to play it out. Like the game mechanics play out in your mind, right? But if we have a digitized version, if I can play against my friends online, then all the inputs and outputs, the full state of the game is stored digitally, so there's no reason it can't be played.
Yeah, and I'm just not good enough at Magic, I think, to understand the strategy like I do chess, so it's harder for me to predict what the problems would be. But it seems to me it has some similar elements where there's some probabilistic things going on. I guess with chess, you can always see what your opponent is up to. And in games like Magic the Gathering or Pokemon, even Hearthstone, you don't see your opponent's hand. And then, like you said, there's some things that are open to interpretation if you're actually playing a human.
And what I actually expect if people started taking AI approaches to Magic the Gathering seriously is that you would expose weaknesses in the game design. I don't follow Magic super close, but I understand that from time to time, someone figures out just a couple combination of cards, which is like an instant win, and they have to revise something because a clever person noticed sort of almost a hack in the game.
Yeah, you bring up a really good point with things, not just like Magic, but even Settlers of Catan. Basically, I don't know what you'd call it, like Neo games, some newer stuff that you might find at a game library, where balancing those games is so hard. I could see that tripping up an AI, or an AI tripping you up and was saying, "Hey, Wizard of the Coast, you got to fix it." Oh,
Right.
that's fascinating.
Well, yeah, that's exactly right. It's going to see that faster than you are. Yeah, it's kind of wonderful that chess has been a relatively. I'm sure if I looked into the history of it, it's evolved, but it's been relatively balanced for quite some time.
One thing I noticed when I was looking up information for this episode, it seems like people are almost bored with the normal chess. And I think AlphaGo, but maybe it was one of the other engines, where they're starting to look at, okay, and I think you had an episode about this. What if we play cooperative chess? And they're starting to tweak little rules of the game and then throwing the engines at that.
Yeah, it's interesting. I think the engines are going to win at all those games because of they're so well suited to the fully observable board and the back and forth minimax strategies you can use for chess. But a few variants might at least keep the game interesting for players. I think it was, if it wasn't Kasparov, maybe it was, who was the other famous guy, Bobby Fischer before him. One of those two guys said they were really pushing for like a certain randomization to the beginning of the game just to bring excitement back to it.
Hmm. That would definitely work. That would make it really intriguing.
Or the other interesting direction, something we looked at a little bit when I was in grad school, is a version called Kriegspiel, where you cannot see your opponent's pieces, but you can attempt to make a move, and you will either be told your move succeeded, your move resulted in a capture, or you cannot make that move, it's illegal, in which case you get to request again.
Oh, wow. I'd have to think about that for a while. I'd be interested to play that.
I'm not sure you would actually.
Oh. What was it really frustrating?
Well, also, and maybe a true chess player like yourself would be better at it, but sort of mind numbing in. Not only am I trying to develop my strategy, but I don't even know where your pieces are. So I'm playing against this probabilistic,
I
thing.
think if I were allowed to put little placeholders so I didn't have to hold as much in my working memory, that I might have a better time with that. But if I didn't get a little bit of a handicap, a little bit of odds, I would have trouble.
Well, one of the interesting things about Kriegspiel was to develop a strategy in which you attempt to make moves you believe will be illegal because you get to take the turn again, and then you've gained new probabilistic information.
That makes sense. That seems like a good strategy.
So certainly the better domain for a computer to play that way than a human. But maybe we'll have some chance at winning in the Kriegspiel tournaments should they come into existence.
I kind of hope they do. That sounds fun.
Well, Becky, thank you so much for humoring me and checking out this paper and having a long discussion about it and the world of chess.
You're very welcome. Thank you for suggesting it.